Hello, this is your Graphing Inequalities and Piecewise Defined Functions review for your Embedded Assessment 1. I have the student rubric that we need to keep referring to make sure that we answer everything completely and that we get an A+ on this pseudo take-home test. Okay, so start with Matt works at a restaurant. He earns $9.50 per hour. Write an equation that indicates the amount of money in M dollars that Matt can earn as a function of the hours H that he worked. So write an equation is what I need to do first. I would say that hours times money is how much money he's going to earn. So M equals $9.50 per or times H. Now, it says to write it as a function or write a function, so I tend to want to make this function notation. So this being M of H is 9.5 H. Usually we don't write dollar symbols in our equations or in our functions. We also don't write multiplication between numbers and variables. So this would be a more simplified and a better answer. You also could have put the 0 at the end of the 50 cents. That is, give or take. But there is my function in terms of hours and money. Remember that we changed this 10 to a 0, so you should have made that correction on your review. Matt works at least 0 hours, which makes sense, and not more than 25 hours per week. So he's a part-time employee. Describe the reasonable domain and range for your function from part A. Okay, so domain and range. So domain is going to be my independent variable, which is hours. So I'm going to just make myself a note out here. And my range is going to be my money that I earn, or that Matt earns, I guess, not me. So your domain is going to be 0 hours. So everything, all the hours greater than or equal to, so this is 0 is less than or equal to, H is less than or equal to 25. That's the max amount of hours he works. He may be a student. And then I've got my 0 money. If Matt works 0 hours, he gets 0 money. For M of H, excuse me, is less than or equal to. Now I've got to do some math over here to the side. So I've got to do $9.50 times the max number of hours, 25. I already put that in my calculator and I get $237.50. So 237.5 is where my range is going to end. All right. The cost of any food that Matt buys while working is deducted from his earnings. So we set up here the max amount of money he can make in 25 hours a week is $237.50. But he's going to eat there, okay, because he works at a restaurant, so he's going to eat there, and then they'll just take it out of his paycheck, okay? So we need to write an inequality that represents the possible amounts of money he can earn after buying food. So how I interpret this is worded really strangely, but how I interpret this is that the most amount of money he can take home is $237.50. But if he's there, he just, if you work at a restaurant, you just might get hungry. You might work over the dinner hour or whatever. So, you're going to want to say, oh, well, he earns $9.50 minus the food that he buys. Well, food is not one of our variables. Okay, we have hours and we have money. We don't have food as a third variable here. So this isn't going to work, okay? What we can say is that the amount of money that he earns, okay, is going to be less than or equal to how much money he makes, which we know he makes $9.50 per hour. Even if he worked more than 25 hours, this would be true. So we could make a domain off to the side that said, specifically the $25, but, it's kind of doesn't matter. If we put a 25 in there, this is the max amount of money that he can earn. Now, so this is how much he'll take home. This M is how much money he'll take home. this is how much money he actually earned. And he could earn the more than he takes home or equal to how much he takes home. But he's never going to make more. Take home more than he earned, right? Okay, hopefully that all made sense. Now we need to graph this inequality. So I know that if he has 0 hours, he makes 0 money. And I know that if he works 25 hours up here, he's going to make about 237. So I'm going to have to guess just a little bit under 240. I really only need 2 points to make a line, and this is going to be a solid line because this is his maximum amount. And when I graph this, I'm not going to graph past, oh sorry, it's kind of off the screen. I'm not going to graph past 25 because he doesn't work more than 25 hours. So things kind of drop off right here. He doesn't have any hours past 25, okay? And everything in here is how much money he can take home. He can earn up to the line, but below the line is how much he might take home if he eats at the restaurant. Okay, so now it says determine, I'm sorry, I skipped a step. We should probably test a point. I just know this is true, but I keep forgetting that you guys might not know that I should shade below the line. So let's do a test point. Let's do 20 and 30. Let's do this test point right here. 20, 30. So I'm going to put that into my equation. So 20 is the amount of hours worked. And it should be greater than, right, 30. So let's put that in the calculator. 9.5 times 20 is 190. And that is greater than or equal to 30. So 30 is less than or equal to 90, so it's true. So that point is a solution on this inequality. Okay. All right, now we'll move on. Part E says determine whether the ordered pair 1521 is a solution of the inequality you wrote in Part C. All right, so let's look at 15 and go up to 121. 120 is right here. So yes, for my graph. So yes, the point is in the shaded region on the graph. So that's one way we could do it. Or another way we could determine if that was a solution is we can use our inequality. So 15 is hours worked, so 9.5 times 15, greater than or equal to 121. So when I put that in my calculator, 9.5 times 15, I get 142.5. That is true. So he earned $142.50, but he only took home 121. Why is that? Because he ate there. Okay, right? So that's how we're going to interpret. It says that if so, interpret the meaning. So my interpret is, so you can either use your graph or use your equation, and then I have to interpret. So the meaning is Matt earned $142.50. But he is taking home $121 because he spent money on food. Money on food at the restaurant. All right. Number 2. Ben has been working at the restaurant longer than Matt, and he earns $10 per hour. During some weeks, he works more than 40 hours. The hours he works beyond 40 are considered overtime. For overtime pay, he earns double time. Ooh, that is a good deal. At $20 per hour. Excuse me. Write a function, b of h, that will give Ben's pay for working 40 hours or less. Okay, so that's a pretty straightforward. B of h equals $10 times hours. So that's it. There's nothing else. This is for every hour up to 40, right? Has to stop at 40, but we're going to have to make a domain and range in part B. So domain is hours, right? So he can work 0 hours, and he can work up to 40. And then the range, which is his money, okay, he can earn 0 money, and that's his B of H. And if I put 40 times 10, that's $400. Okay. Number 3, write a function, b of h, that will give Ben's pay for working more than 40 hours. All right, this one's a little trickier. All right. First of all, we know he makes $20 an hour for the first 40. Okay, so I'm going to take hours, and I'm going to subtract off those 40, because the original 40 is up here. So I don't know if you can tell yet, but we are building a piecewise function. So anything, this number right here has to be greater than 40, and we're going to say that later. But right now, we have to subtract off that original 40 that goes up here. Likewise, we have to subtract or add on the $400 that he already earned, because we need to know how much his total amount on his paycheck's going to be. So we got to give him the 40 hours he'll get up here. So if I put a 40 here, this is 400. That's where this is coming from. And I'm taking off the 40 that I'm putting in there. Now I need to simplify this little monster. So you have 20H minus 800. Right? This is the distributed property here. Plus 400. Now if you simplify that, you have 20H minus 400. Okay, so that is my final function right here, my final answer. All right, always give functions simplified, right? As smallest amount of terms possible. You can think of this a little bit different. I know some of you are, this way is the most simple way to me to figure out all the hours and the money and then simplify it down. But a lot of you are really good at this, and I want to show you another way. Up here, 40 hours equals $400, right? Up at the top here. Well, down here, if I start with 20H and I put in a 40 there, if I put in a 40, so 40 times 20, that equals 800, and I need it to equal 400. Right? So the only difference there would be to subtract off the 400 that is messed up right there. And so do you see that I get the same function? And so like to me this is like I can simplify that. I don't have to show all this step on the embedded assessment. I don't want you to think that, but I do need it to be the right answer. So a couple different ways to think of it to get to that piece that we need. Okay. So now identify a reasonable domain and range for the function in this context. All right, so domain, range, just like before, domain is hours and range is money. Okay, but this time my domain isn't going to go down to 0. Remember, it has to be bigger than 40, so H is greater than 40. And there's no top limit. He can work, physically, there is, right? In 1 week, there's only a certain number of hours in a 7-day week. We're not going to get all into that, right? We're just going to say there's no limit. And physically, your body cannot work 24 hours a day, 7 days a week, yada, yada, yada. But, theoretically, there's no limit, all right? And then his range is going to be B of H. And again, he's going to start at everything bigger than $400. That was supposed to be a bracket. Isn't it beautiful? All right, last problem. Remember, we don't have to do number 5. Hopefully you've scratched that off already. We're not graphing that. We're going to save that for Algebra 2. All right? Write a piecewise defined function based on Ben's pay. Okay, so here we have part A, and we have 2A and 3A, and we're going to sort of squish everything together. So we have B of H, and we're going to make our two pieces. First we have the $10 per hour when we have 0 is less than or equal to H is less than or equal to 40. Okay, equal 40 perfectly is still going to fall in the $10 an hour. Then we have our 20H minus 400 when H is greater than 40. All right, and we don't have to graph it. We are done. I will see you later.